Hypothalamus Artificial Intelligence, HI. Digital transformation powered by autonomous and intelligent algorithms in real time. Presents its solutions based on artificial intelligence decision-making for integrated poultry production planning. HI has the support of its technological allies, General Algebraic Modeling System, GAMS, and IBM, producer of CPLEX Optimization Studio. Both products are incorporated into HI's artificial intelligence solutions. The submission is based on a third-party report, case, SADIA, and clarifies that it is not the result of HI's professional work. Value proposition. To economically evaluate the benefit of the value proposition associated with the mathematical optimization models applied to the poultry sector, information from the SADIA case related to the integrated poultry production planning. Case study, Integrated Planning for Poultry Production in SADIA. The case has been published in the journal Interfaces in 1996, with the title Integrated Planning for Poultry Production at SADIA. In 1944, in Concordia, in the western region of the state of Santa Catarina, Brazil, Atilio Fontana created SADIA Concordia S.A., starting with a wheat mill, where he also raised pigs, which he sold in exchange for local crops. SADIA became a global processor of pork, beef, chicken and turkey foods, as well as pasta, margarine and desserts. A national leader in all the activities in which it operated, it was one of the largest food companies in Latin America and one of the largest exporters in Brazil. In 1994, it processed 300 million chickens and 11 million turkeys a year. SADIA's poultry production was around 21% of Tyson Foods, the largest North American producer at the time. In 2008, SADIA had about 20 industrial plants that together produced more than 2.3 million tons of food, serving more than 70,000 direct points of sale in Brazil and exporting to more than 100 countries. In 2009, the company announced a merger with its main competitor Perdigão, forming BRF, Brazil Foods. In 1994, the use of mathematical models had represented savings of $50 million over a period of 3 years. By 1994, SADIA was a national leader in all the activities in which it operated, in addition to being one of the largest food companies in Latin America, and one of the largest exporters in the country. It processed 300 million chickens and 11 million turkeys a year. SADIA's poultry production was around 21% of Tyson Foods, the largest North American producer. In 1994, in the Brazilian market, SADIA has about 680 products, distributed in more than 300,000 points of sale. In the international market, it exports about 1 million products to more than 100 countries. In 1996, the company was composed of 19 companies with 24 industrial plants throughout the country. The group generates employment for around 30,000 people. SADIA has annual revenues in the order of 2,500 million of American dollars. Since 1990, SADIA has been using mathematical models to support decision-making in its production chain. This generated profits, avoided cost, estimated at 50 million of American dollars in the first 3 years of operation of the models. SADIA's applications were pioneers in the poultry industry and can be adapted to other animal processing industries. The use of the mathematical model has led to improvements in conversion of feed to bird weight, use of birds in products classified by weight ranges that control for weight variation within bird groups, daily production control, reduced time to meet demand, and studies on product demand and prices. Poultry production modeling must consider decisions in poultry production. That implies assign products to plant's daily production plan. For each plant, select groups of chickens to provide raw material for their needs. That implies technical limitations. Plant capacity, production availability, process performance, production costs. Primary integration structure. Normally, the production chain of a company like SADIA involves a set of owned farms and integration with other farmers through technical support and technology transfer agreements. In this way, there is the greatest possible availability of farms. SADIA's supply chain is made up of two links, the primary one on farms, which produces poultry, and the industrial one in factories, which produces meat products. In 1994, SADIA's supply chain had 7 plants, each specializing in a specific product type. The table indicates the number of growers, the number of birds and the average weight. Commercial products and weight ranges. Perhaps this corresponds to the biggest problem that SADIA must face, since the characteristics of the market depend on many factors that make it very varied. These factors may depend on regional, geographical areas where the product is consumed, economic classes that consume, seasonal, the time of year in which is consumed. Combining solutions for a large company becomes a fundamental issue in decision-making planning that affects the entire production chain throughout the year. The image shows the genetic chain of grandparents and breeders at SADIA, whose balance is decisive for the productivity of the process. The image presents the activities of chicken processing. PIPA, Integrated Poultry Production Planning. Optimize the decisions of the stages of production. That implies planning, programming and control of activities. PIPA answers questions such as: how many grandfather chickens should you buy? When should you discard and replace the flock of grandparents? When should you slaughter chickens? How much of each product should you locate on each floor monthly/weekly? How to match the number of chickens slaughtered and the capacity of the plants? The diagram presents the connectivity of the system's models. PIPA stands for Integrated Poultry Production Planning, developed by SADIA. PIPA encompasses the 3 hierarchical levels of planning: strategy, tactics, and operation. PIPA is backed by predictive analytics, for statistical process support, and prescriptive analytics, for industrial process optimization. On a strategic level, PIPA makes the following decisions: matches resource capacities, investment analysis, and plan the flow of eggs to incubators, broilers in sheds, chickens for plant slaughter, and products to markets. On a tactical level, PIPA makes the following decisions: bird planning. That implies synchronize the cycles of grandparents, breeders, and chickens, and determines the optimal grandparent and breeder replacement policy. Site planning. That implies plan the slaughter and production of chickens for each site, and determine how many chickens should be kept daily to provide the number and weight distribution of birds for the month. At the operational level, PIPA makes the following planning and control decisions: herd, determine the herds that will be sacrificed daily. Plan production of each site for every 15 days. Change, determine weight distributions for production. The volatility of bird weight throughout their age should be carefully planned, as the attention of the markets depends on it. This estimation process must be carried out using predictive analytical models that provide the probabilistic distribution of the bird's weight as a function of age. The table presents the conversion of feed to weight gain due to the implementation of PIPA. The increase in weight and the decrease in volatility is evident. A key part of the success of the PIPA system is the coordination of all aspects related to the rearing of multiple types of birds, which supply commercial products for different markets and require a fully controlled fattening process, considering the production of concentrated feed for birds of different ages and the supply of such feed on multiple farms. Since the implementation of PIPA, the gap in bird weight volatility has narrowed, because if birds of a certain age are provided with food for another time, resources are wasted. If birds are fed at an advanced age, they will not be able to assimilate nutrients. If, on the other hand, they consume food for a younger age, they will not gain weight as expected, because the nutrients are not provided in the right amounts. This synchronism became an economic benefit in SADIA. The table presents the dimensionality of the models run in 1994. Although they were large models at the time, to-date computational power makes these models look like toys. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." Thank you for your attention.